When you first hear about AI models, it is easy to assume they are built by carefully programming every possible answer. But that is not how it works. In reality, most AI models start out knowing absolutely nothing. No language. No images. Just random numbers making random guesses. Then, over time, they are trained using large amounts of data and repeated adjustments. Eventually, those guesses become accurate enough to be useful. So today we are going to walk through how AI models are actually trained and how a system goes from randomness to something that looks a lot like understanding. Chapter 1: What an AI model is. An AI model is a mathematical system designed to process input and produce output. It takes something in, like text or an image, and generates a prediction. That prediction could be the next word in a sentence, a label for an image, or a response to a question. At its core, the model is made up of layers of calculations controlled by parameters. These parameters determine how the model behaves. Chapter 2: Starting with random parameters. When a model is first created, its parameters are usually set to random values. This means its initial predictions are not meaningful. If you ask it to complete a sentence, it will likely produce something incorrect or nonsensical. This is expected. Training is what transforms those random parameters into something useful. Chapter 3: The role of training data. Training requires large amounts of data. For language models, this data consists of text from books, articles, and other written sources. For image models, it may include labeled images. The model uses this data to learn patterns. The more varied and representative the data, the better the model can learn. Chapter 4: Making predictions. During training, the model is given an input and asked to make a prediction. For example, it might be given part of a sentence and asked to predict the next word. At the beginning, these predictions are often incorrect. But each prediction provides information that can be used to improve the model. Chapter 5: Calculating error. After the model makes a prediction, the result is compared to the correct answer. The difference between the two is called the error. This error tells the system how far off its prediction was. A large error means the prediction was very inaccurate. A small error means it was closer to the correct answer. Chapter 6: Adjusting parameters. To reduce error, the model adjusts its parameters. This adjustment is based on mathematical techniques that determine how each parameter influenced the prediction. The changes are usually very small. However, when repeated many times, these adjustments significantly improve performance. This process is often called optimization. Chapter 7: Repeating the process. Training is not a one-time event. The model goes through the same steps repeatedly. Input is provided. A prediction is made. Error is calculated. Parameters are adjusted. This cycle happens thousands or millions of times. With each pass, the model becomes better at recognizing patterns. Chapter 8: Avoiding overfitting. One challenge during training is avoiding overfitting. Overfitting happens when a model becomes too focused on the training data. Instead of learning general patterns, it memorizes specific examples. This can make the model perform poorly on new data. Training methods are designed to balance learning with generalization. Chapter 9: Fine-tuning and improvements. After the initial training phase, models are often refined further. This process is called fine-tuning. It involves training the model on more specific or curated data. Fine-tuning helps improve accuracy and align the model with specific tasks. For example, a general language model might be fine-tuned for customer support or coding tasks. To wrap up, AI models are trained by starting with random parameters and gradually improving through repeated learning cycles. They use large datasets to identify patterns and make predictions. After each prediction, the model measures error and adjusts its parameters to improve accuracy. This process is repeated many times until the model performs reliably. Careful training helps ensure the model generalizes well rather than simply memorizing data. Although the process involves complex mathematics, the core idea is a gradual improvement based on feedback. This has been a mini Leviathan production. If you enjoyed it, check out our other videos. See you in the next one.